Okay, so today we're going to be talking about adding and subtracting rational expressions. The last 2 days we've been doing multiplying, dividing, and simplifying. So we're going to go a little bit further into this. Now, remember when I said you have to know how to factor? We're still going to be factoring. So you still have to know how to factor. It's not going to go away, okay? So if you came in here for some extra help for factoring, awesome. You should be pretty good at this by now. It should be coming much quicker than it was day one, agreed? Yeah, because day one was a little rough, so we should be moving quite a bit faster through this lesson. All right, go to the next page. All right, so just a quick reminder here. This is 4th grade. So let's see if we can pull this together real quick. I have 2/15 plus 3/25. In order to add two fractions together, what is it that I need? Common denominator. Good. And what is my common denominator going to be? Okay, question. Can I turn 15 into a 5 using multiplication? So let's rethink that answer. Are we going to use 5? 5 is my least common divisor. That's what you can divide into both. The smallest number you can divide into both, but that's not what our common denominator is. So think bigger. Awesome. Say it again. 75. Good. So I can turn a 15 into a 75, and I can turn 25 into a 75, right? Using multiplication. Okay, so what would I have to multiply 15 by to get 75? So what did I have to multiply 2 by? 5 as well. Why is it that I have to multiply both the numerator and the denominator by 5? Yeah. What's 5 over 5? 1. What happens when I multiply something by 1? It stays the same. So is the value of 2/15 changing if I'm multiplying by quote-unquote 1? No. That's why you have to multiply the top and the bottom. Okay? So 2 times 5 gives me 10. So there's your numerator for the first one. Okay, second fraction, what did I have to multiply 25 by? So what do I have to multiply 3 by? Which gives me? Excellent. Any problems so far? How do I add two fractions together? Just add the numerators. Good, which gives me? Over. Excellent. Problems, questions, concerns? Okay, so when we're adding together rational expressions, we're going to need a... What do we need in order to add together two rational expressions? Say it again. Speak up. Common denominator. Okay, so in order to add two rational expressions together, we're going to need a common denominator. Okay, so that's where that fun factoring comes into play again. Okay, so we're going to go ahead and find the least common multiple of each one of these. So the first step is to factor everything. Okay, that's your very first step. We're going to factor everything as completely as we possibly can. Okay, factor till you can't factor anymore. And then step 2 is going to be to create your new denominator. And we're calling it denominator because we're going to be doing these as fractions. Your new or your common denominator. Okay. So if you don't have your notebook out, you're definitely going to want it out. These are very long. Generally speaking, each one takes about a half a page. Okay? Are you guys ready? Okay, I'll wait. How about now? Okay, so we have 4x squared minus 36, and we have 6x squared plus 36x plus 54. So again, we're going to start by factoring as much as possible, right? First one, 4x squared minus 36. What do you notice? It is difference of two perfect squares. What else can I do? GCF of 4. So if I take out a GCF of 4, factor out a GCF of 4, what winds up in my parentheses? Good. X squared minus 9. Excellent. What do you notice about that? Oh. Great. Very nice. Are we okay with that? Okay, next one. What do you notice? Yeah, GCF of 6. Good. What goes in those parentheses? Good. Are we okay with that? All right, now what? Sure. How's it factor? X plus 3, X plus 3. Great. Okay, so now we're going to decide on how we're going to create this common denominator. Okay. First thing you need to do is look at your numbers here, 4 and 6. I need a number that I can turn both of those into using multiplication. I want to be the smallest one possible. 12. 2 is the least common multiple, right? It's what you can divide into both, but it's not what's going to give us the number that we need. So it is going to be 12. Good, because 4 times 3 is going to give me 12, 6 times 2 is going to give me 12. Could I use 24? Yeah, it's just not my least, which means chances are I'm going to have to simplify again later on in the problem, which I don't want to have to do. Okay? All right, so now we have to look at what they have in common. So I've got an x minus 3 here and an x minus 3 here. That's what I meant. Sorry, x plus 3. Good morning. All right, so they both have an x plus 3, which means we're going to share that one x plus 3. Okay? Since they both have it, we're going to share it. We only have to write it once. Look what I have left over. Okay? I have to have both of those as well. That's not red. So I have to have another x plus 3 because of this one here. And I have to have an x minus 3 because of this one here. Okay? You could do that. I wouldn't, though, because when we're doing these problems, you're going to want to see it written out. Okay? So that would be the common denominator if these were the denominators of two rational expressions. So they're not going to be pretty looking necessarily, but you just have to remember if they share, you write it once, and then each individual that's left over you have to have. You ready to try another one? We're going to do this a bunch of times. Okay. All right, so 3x squared minus 9x minus 30. And 6x plus 30. So how am I going to start, guys? GCF, good. And what is it? Great. I got to start learning your names. I'm going to start calling you out. Amanda, what goes in my parentheses? You're going to take each one of these and divide it by 3 to tell me what goes in the parentheses. Good. Good. Beautiful. Nice job. Vanessa, who are you? Show your face. Hi. What does that factor? Great. We're okay with that? All right, next one over. Let's have Brandon. Great. Okay, so let's decide what our common denominator is going to be. Marissa, I've got that 3 and the 6, right? What am I going to use? I want the smallest one that I can turn them both into. Okay, that's close. Sure, I could use 12, but I'm going to have to simplify. Think about it. Can I turn 3 into 6? Okay, so we're looking for the smallest number that they can both be, essentially, using multiplication. Okay, so I've got a 3 and a 6. I know I can change 3 into a 6 by multiplying by 2. I know I can keep 6 the same by multiplying by 1. So the number that we're going to use there is 6. Are we okay with that? All right. All right. Do we share anything?
No.
What does that mean? Got to have one of everything. So I have to have an x minus 5, I have to have an x plus 2, and I have to have an x plus 5. No. And the reason being is multiplication is commutative. So I like to have the number out front. That's just how we normally write things. But the rest of this, the x minus 5 and the x plus 2, if you flip-flop those, it's the same thing. It's like saying a times b is the same thing as b times a. Okay? That's it. That's it. So that would be your common denominator. Okay? Ready to try another one? Okay. So why don't you guys go ahead and get it started, and we'll go over it in a second, okay? 5x squared plus 15x plus 10, and 2x squared minus 8. Okie dokie. I have to learn your names. Okay, we're still doing this. Stephanie. Hi, Stephanie. First one, how do I start? Good. GCF of 5. What goes in my parentheses, please? Good. All right. How about Simone? Hi. Factor for me. Thank you very much. Let's have, Caitlin's not here. Ludmila, over here. Great. Bailey. Perfect. Nicely done. Okay. So let's talk about what we need. We have a 5 and a 2. What's it going to be? Great. Do they share anything? Yep, they share that x plus 2, so we're just going to write that once. What else do we need? Great job, guys. How do you feel? Okay, so now let's actually put it to use, right? So we actually have to use it. Okay, so now we've got our rational expressions, and we want to add them. Yes, dear? Nope, just once. They both have it. You write it once. Okay, so we have two fractions we want to add together, which means I need a, and now we know how to find those common denominators. We're going to factor, and then we're going to decide what it's going to be, right? So we're going to walk this out step by step. You're going to show your work for every step. It's going to be legible so that I can read it. When you show your work, all your numerators should be on the same line, your denominators should be on the same line, and then you should do the same thing on the next line down. I've seen some really crazy things over the past 2 days with how you guys write your notes, so let's try and be a little more organized, okay? All right. Yeah, you're going to need some space. Gia, what was?
1 over x squared plus 5x plus 4 plus 5x over 3x.
You guys ready? Okay, I'm going to be picky about how you write things. So next step, you're going to have an equal sign. And we're going to start with the factoring. Okay, I'm going to keep my numerators just as they were, and we're going to factor my denominators. So first fraction, denominator. How does that factor? Beautiful person I don't know. What's your name? John. Thank you. Okay, denominator. Let's Pat. I know Pat. Doolin, right? Okay, how's it factor? Thank you. Okay, any problems with that? All right. Okay, so now let's talk about what my common denominator is going to be. 3, good, I got to have that number, right? I've got a 1 here. It's assumed. I have my 3, so I definitely need a 3. Okay? X plus 1 is what they share, good. And then my x plus 4 is left over. Excellent. Are we okay? Okay, so here's where the tricky part comes in. My original numerator was 1, right? I went from here to here. What's different? There's a 3 in front of the 1, right? So now I've gone from having a 1 to a 3. So what do I have to multiply this 1 by? 3. Excellent. Okay, so you're multiplying the numerator by what's new in the denominator for that fraction. Okay? Okay, so we have our 5x, right? Look at my denominator, 3x plus 1. Here's what it is now. What's new? X plus 4, so the x plus 4 goes here. We're going to do this a bunch of times. Are we okay? Okay. Where did I get x plus 4? Okay, so you see this original denominator, 3 times x plus 1? Here's our new denominator, right? What's different? What's new? The x plus 4. So here's how this works, guys. If I have 5x, 3x plus 1, right? If I multiply this by x plus 4 and this by x plus 4, does it change it? What's anything over itself? 1. So if I multiply 5x over 3 times x plus 1 by 1, does it change it? So that's why you have to do it to both the numerator and the denominator, okay? Because essentially if those canceled out, I'd be left with what I started with, okay? All right, let's keep going. So now I need to multiply, right? 1 times 3 is 3. What am I going to do with that 5x? Distribute it, good. 5x squared plus 20x. We're going to keep that denominator. You doing okay so far? Yep. Five x times x is 5x squared. 5x times 4 is 20x. And the last step is just to write that numerator in descending order. Okay? 5x squared plus 20x plus 3. Okay. Generally, what we would want to do is we would want to look at that numerator and make sure that it doesn't factor any further so that nothing else can cancel out. I'll tell you right now that it doesn't factor, so save us a little time. Okay? But you're always checking, can I factor again? If I can, factor. Okay? No. But I would think it would be ugly. Yes, absolutely. Yep. Factoring fun. We like factoring. Factoring is our friend. Right, Pat? You guessed so. Are you ready to try another one? All right, let's try another one. All right, I want you guys to go ahead and give it a shot. Okay, follow the steps that you just did. Let's see if you can do it. We'll go over it in a minute. I think maybe we need to add in an additional step that's creeping people out. Okay, first fraction, how do I factor it? Yeah, any problems there? Second one? Are we okay with that? Okay. What's my common denominator going to be? Excellent. So just so some of you are having trouble moving from 2 fraction to 1 fraction, so I'm just going to put in an extra step so you can see how we did that. Okay. So I'm leaving my numerators as they were, and I'm writing both fractions with the new common denominator. Are we okay with that? Okay, so the next step is to see how we've changed. So this was my original denominator. This is what it is now. What's new? So you need to multiply the top by 4 as well. Okay? The reason being is if I take and I simplify out or cancel out those 4s, I'm left back with your original. Okay? Second one, here's how you started. Here's what it is now. What's new? Do you see how we're getting that now? Who said no? Okay. Look, what if I did this? Is this the same as this? Well, factor form. Yeah. Okay, so what we're doing is we're figuring out if this is my new common denominator here, I have to multiply the numerator by the same thing as the denominator. So however, whatever we've tacked on in the denominator that wasn't with the original, I have to tack on in the numerator. I just made a mess. Okay, let's try this again here. 3x, 4x plus 2, x minus 6, and we tacked on a x minus 6. Okay, now we're going to go from 2 fractions to 1. Okay, I'm going to write this with one common denominator. Are we okay there? Okay, in the numerator, 1 times 4 gives me plus, is that plus? Right, now we distribute. 3x squared minus 18x. Okay. Last step is just to rewrite it pretty. You would see if the numerator would factor. It doesn't, so that's it. Or try another one. Okay. Okay, through one subtraction. Okay, so the next thing we're going to talk about is subtracting. We do it the same way as addition, except instead of adding the numerators, what are we doing? Okay, so it's not that big of a deal. So what we need to remember is if I have something like 2x minus x plus 4, what do I have to do here? Say it again. Yeah, I distribute through that negative. When we're subtracting polynomials, we have to make this addition, change, right? You distribute that negative 1 through. Keep change, I think is what you guys called it in junior high, right? Okay, so when we're subtracting, we just have to keep that in mind. So that's just a little reminder. Okay, you ready? Gia, you're going to read again to me. What is it?
I over 5y squared minus 125 minus 4 over 3y plus 4.
Okay. So let's start with that factoring. Denominator, first fraction, how does it factor? Okay, that's our GCF, good. But what can I do to that? Difference of two perfect squares. So are we okay with that factoring piece? Okay, second fraction. How does that factor? Okay, good. So now let's decide what our common denominator is going to be. I'm sorry? 15, good, there's our number. Y minus 5 is what's alone. Y plus 5 is what they share. Good. Okay. So here comes the part where we decide what's new. Okay, good. So in this one, we have the y to the y plus 5. We have the y minus 5. What's changed is we went from 5 to 15. How do I get from 5 to 15? Multiply by 3. Good. Okay. All right, over here, I have the y plus 5. I need, good, 3 to 15 has to be, and I also need the y minus 5. So I need both. Okay. So first one, this is going to become 21y. Okay, now be careful. What is it that I'm going to be multiplying by? 20, and I want it to be what? Negative. I want that negative with it. Okay, so I'm going to be distributing a negative 20. Okay, so this becomes minus 20y plus 100. Distribute. 5 times 20. Okay. Last step. 5 times 4. Yep, y plus 100 over 15 times y minus 5, y plus 5. And that's it. Soon. Very soon. What? Somebody said something. -20 times -5. You're distributing. Distribution. Okay? Your homework is page 4. 4? 4. Okay? Your weekly project is going to be due Tuesday. Reason being is you should have been able to do 6 through 10. 1 through 5 is the stuff you learned today. I want to give you a day to come in and ask for help if you need it on Monday. So it'll be due Tuesday. You'll have a quiz on Tuesday on simplifying, adding, subtracting, multiplying, dividing, rational expressions. Okay?